Welcome to a geometry tutorial on Apex Checkup Problems 2.6. 2.6.2. Very cool pen, by the way. Not what I wanted, but that's okay. So what we're going to talk about is showing that these two triangles are similar. And we do that by recognizing that they are proportional. So we look at each of the sides, first of all, and we're going to look at the ratios. The order that the triangles are named in matters. So in this case, it tells us we're looking at triangle DEF is similar to triangle ABC. All of that matters because it tells us that angle D and A are congruent, E and B are congruent, F and C are congruent. That also helps us know the opposite sides are the ones that we're looking at, and I'll have to change my color to draw on the triangle. So what we want to do is look at the ratios. So for example, if angle D and angle A are the ones that are congruent, then those opposite sides are the ones that we need to pair up. So 80/16. And notice I put the first triangle on top and the second triangle on the bottom. We have to make sure that that's equal to the next set of ratios, which would be E, which is 60, over the side opposite B, which is 12. And then lastly, we want to look at the third ratio, which I don't think we have to do too much work to figure that one out, that we're looking at the 75/15. Now, in order for these triangles to be similar, each of these ratios must reduce to the same common factor. So let's check. We have 80/16, and see, that would reduce, so we could divide by 8, right? And we would get 10/2. Oh, that's looking like a 5/1, right? So let's see. 60/12. Let's see. Oh, 12 goes into 12 once. 12 goes into 65 times. There we go. That one works. That's check. Next one, 15 goes into 15 once. Let's hope it goes into 75 5 times. Let's see, 15 times 5, 25, add 2. Yes, it does. Okay. So we have the fact that these two triangles are indeed similar. But now, what if we're asked a second question? So the first question was, are they similar? Question number 2, what is the scale factor? A scale factor is a number we multiply by one object to change its size. So for example, if you've ever been to Legoland and you've seen like the Empire State Building at Legoland with all the little itty bitty windows, it's pretty amazing with the tower and all that, and the little people at Legoland and the trees and all those things. They're all built to scale. That would mean that if the Empire State Building were 1,000 feet tall, then and at Legoland, let's say this one was 1 foot tall, then everything would have the same scale factor. The windows would have the same scale factor, the trees would have the same scale factor, the height of the elevators, everything would have the same scale factor. In other words, they would be reduced. So if they are being reduced from a large object to a small object, we take the number of the large object. We want to figure out what number do we multiply that by to get the small object. Well, in this one, case I made it pretty easy, we would multiply by 1 over 1,000. Basically, it's that proportion we were just talking about before. So the key on the scale factor is you're asking yourself, what would I multiply by? So in this particular set, so in the Empire State Building, it'd be 1,000. Going back to our problem here, we would be looking at these two triangles. If you look, we went from a large, you can now kind of see what I wrote. Let me see if I can change the color. We went from a large to a small. That would mean that my scale factor is going to be something that's going to shrink it. When I'm going from large to small, my scale factor is going to be a fraction where the numerator's larger than smaller than the denominator. So it won't be 1 over 5. My scale factor actually is going to be 1 over 5 because we're going large to small. And how you check it, and this is the check, you take one side, take your 80, multiply that by 1/5, and make sure you get the corresponding side, which we do, which is 16. So then we know we have the correct scale factor. And that concludes our tutorial on section 262.